Hi students, today we are going to see an interesting topic called galvanizing, and specifically we are going to see about hot dip galvanizing process. Okay, let us get into the topic. What is galvanizing? It is a process of applying a protective zinc coating to steel or iron to prevent rusting. So what is a big issue with iron is rusting. How to avoid this rusting process? So rust is formed when it is exposed to the environment, it reacts with the environment and forms the oxides. Okay, so if I want to prevent rusting of iron, so what I do, I cut off the environment. If I cut off the environment, iron cannot react with the environment oxygen to form iron oxide. So how to cut off this environment? So what we do, we apply a zinc coating over the surface. When zinc and iron are together, okay, so zinc is more anodic than iron. So zinc will act as anode and iron will act as cathode. So this iron gets protected as cathode. Cathodic material is always protected because just hydrogen evolution take place on the surface and at anode oxidation reaction take place. That is, we sacrifice the zinc. So here zinc gets corroded. So by sacrificing the zinc, we protect the iron or steel surface which is underlying. What is the biggest part of this galvanizing is there? If one area zinc is peeled off and iron is exposed to the surface, yet iron is protected. Why? Iron takes the role of cathode, zinc takes the role of anode. So only anode corrodes and cathode is always protected. But when we apply a protective metallic coating, if this coating is peeled off, if I get iron exposed to the surface with a noble metal coating, so what will happen? Now iron plays the role of anode and the remaining surface area coated with noble metal act as cathode. So now what happens? In a short while, a pit is formed on the peeled off area. So that results in not usage of that material. Catastrophically, the whole material is protected, but one area we get a pinhole. So we are the product or the vessel is not in use. So to protect, 100% protection can be given by sacrificing your zinc. Once you sacrifice your zinc, always iron is protected. How this is done? This can be done by hot dipping galvanizing process. So it's nothing but just taking the material, this which has to be prevented, dipping into the solution and removing it off so you get a coating over the surface. Let us see the process in detail. Let us see the process parameters. So temperature at which this hot dipping is done is 440 to 460 degrees Celsius. We want zinc to be in the melted state. Immersion time is 1 to 5 minutes. Okay, as the thickness is required, we can give more time for immersion. Pre-treatment, before dipping into any surface treatment, we need to give the pre-treatment to the surface. So what is it here? As usual, first step is degreasing, removing oil or grease, then pickling. Pickling is carried out with acids. So either HCl or sulfuric acid, we can dip it into it where the dirt and the chemical particle which need to be removed, it gets removed off, and then the washed with distilled water. After that, traces of acid which is present on the surface is fluxed with zinc chloride and ammonium chloride to nullify it. Then after the hot dipping is done, we need to cool it, right? So cooling can be done air, that is directly allowing it to cool naturally, or you can take that and dip it in water. So water quenching can also be done, and coating thickness required is 50 to 150 micrometer thickness based on the applications. Bath composition is the important for molten zinc coating. So what is required here is 98% of zinc in the molten state, and this is the primary material which need to be coated to protect the iron. So corrosion protection is given to the iron or steel surface. So now next we add little bit in traces quantity of aluminium to improve the adhesion. That is, zinc has to adhere to the surface of the iron. So for that we add little bit of aluminium, which improves the adhesion process, and also it reduces the dross formation. Zinc is in the molten state, which is at a higher temperature, more than 400 degrees Celsius. And at higher temperature, this low melting metal, what happens? They start forming oxide layer. And when this iron and zinc react, when the iron piece is dropped into molten zinc, so iron and zinc reacts, where iron slightly melts or dissolve into the zinc while depositing on the surface. This iron particle as well as the oxidized zinc, all these things form a scum or a slag on the surfaces. Okay, or a solid particle which is separating out in the molten zinc. So that is called as dross. So this can be reduced by adding aluminium. Then we add lead 1% to enhance the fluidity, okay, and reduces the again dross. That is phasing out. That is solid form which is coming out, which is an impurity. Okay. Then we have nickel in traces to improve the coating uniformity and reduces zinc pickups. Okay, here and there zinc gets more picked up, so that can be reduced and uniformity is observed when we add in traces quantity of nickel. So the bath contains maximum main ingredient is zinc, and to avoid the problems we add in traces quantity aluminum, lead and nickel. Now steps involved in hot dipping. So first is degreasing. Always surface coating, we need to degrease. So the surface is contaminated with oil or grease. So coating cannot be applied because it will not sit on the surface. Adhesion will be poor. So we need to degrease it. So we give degreasing, and here we do it using caustic solution. Generally acetone cleaning, we do it to remove the degreases, and followed by you can have an caustic solution. Okay, then second step is pickling. Pickling, always we know it is dipping in acid. So to remove any rust, dust, anything lying on the surface can be removed by pickling. Then we put it into fluxing. So here we dip it into zinc ammonium chloride solution, okay, ranging in 30% to remove the oxides and prevent further oxidation on the steel surface. That is, a traces quantity of sulfuric acid or HCl on the surface can be removed by dipping into this flux. Then it is the real process galvanizing. It is immersed at 450 degrees Celsius, and the iron which need to be coated. So what happens? Zinc iron inner layer and outer layer of pure zinc is formed. Okay, then we have quenching process. So what we do, zinc is an anodic material, right? It always reacts with the environment. To prevent zinc to get easily anodized, we apply a passivation layer by dipping into a inhibitor solution, just like example, sodium dichromate solution, so that it avoids the early oxidation of zinc. It is used as only anode, but let the process be slower, right? So that it can be protected, the underlying metal can be protected for a longer period. Then cooling. So this cooling, after the zinc solidifies, slowly zinc gets solidified, forming an protective alloyed coating. Okay, so in this figure you can see zinc, which is gray in color after the metal which is in gray in color, and after coating with zinc we have a white in color. Okay, zinc is actually gray in color. So the process is explained here: alkaline degreasing, then water rinsing, then acid pickling, then we need to rinse it with water, then hot flux to remove the traces of water, and then we have hot air drying, then we have molten zinc where the real galvanizing process take place, 1 to 5 minutes. After that it is removed, and first step is quenching where the passivation layer is formed, then it may be cooled with air. so that solidified product you get it. Then what are the factors that affect this coating thickness? Surface conditions of the steel. So roughness and cleanliness influence coating adhesion. That is, it increases. If it is rough surface and it is very clean surface, we get a very good coating surfaces. Then composition of the steel. High silicon content can increase the thickness. If a steel has a high silicon content, then we can see increased thickness of zinc on the surface. Increasing immersion time does not necessarily increase thickness except in silicon steel. So this thickness increases in the silicon steel but not in all other cases. Advantages of galvanizing. So superior corrosion resistance, as I earlier explained. Even if one area zinc is completely fallen down and the underlying metal is exposed to the environment, still it is getting protected. Okay, so it is a superior corrosion protected. Long lifespan, so 20 to 50 years with minimal maintenance. Strong and durable. So tough coating resist wear, scratches and impacts. So if you give a very tough coating, so it also wear resistance, scratch resistance as well as impact resistance. Cost effective, zinc is cheaper material and the process is also very simple, just hot dipping. Eco-friendly, zinc is recyclable, process has low environmental impact. Applications. So the pictures you can see the galvanized product. Okay. So we have marine, ship parts, docks, offshore platform, railways, train bodies, tracks, bridges, constructions, roofing sheets, beam, fencing, supports, etc. Automotive, car frames, body panels, corrosion resistance part, household, washing machine, refrigerator, air conditioners, etc. So to summarize, so hot dipping is a long-lasting, cost-effective corrosion protection method. Okay, widely used in various areas and offers a highly durable, environmental friendly product. Thank you, students. Let us meet in yet another topic. Thank you for now.